In this video, I'll demonstrate how to integrate a production-ready third-party API into your custom GPT. We'll avoid Replit or any other playground environment. Instead, we'll focus on deploying a real serverless API using Firebase functions. This ensures that you can scale to virtually any number of requests without ever worrying about your server shutting down. And if you'd like to adapt this code for your own custom tools or logic, I will show you exactly how to do that at the end of the video. Let's begin. In this tutorial, we'll connect Google Analytics Data API to our custom GPT to answer questions about my website's traffic. This is a very common project that I often receive as an AI developer. Data-driven decisions are the key to success in 21st century, but the problem is that most of these APIs are not straightforward to work with. First, you have to create a correct query. Then, you have to know how to receive the results. And third, you have to know how to interpret them before you can make use of any of this data. And GPT models streamline this entire process like never before. Instead of spending hours to analyze your data, you can simply ask a question and get an instant response, saving you or your client hours of time. To get started, create a new repo on GitHub and clone it. Then, open it in your terminal and install the Firebase CLI. You can do this with npm by running npm-g install Firebase tools. If you don't have npm installed, then guess what? Ask ChatGPT. Next, run Firebase init functions command to initialize Firebase functions in your current folder. Firebase CLI manages all of the deployment aspects for you, so you can focus solely on coding. Additionally, they provide a generous free usage quota that in my 3 years of working with them, I still haven't been able to exceed. I do hope that this will change soon though. When prompted in the terminal, select Create New Project and enter your project ID and project name if needed. Wait until Google Cloud resources are created, and then, when asked about which language you would like to use to write your functions, select Chinese. Just kidding, select Python. Select Yes to install the dependencies, and now you should see a functions folder in your root directory, which means that we are ready to start coding. In the requirements.txt file, add 2 new dependencies. The first one is the instructor library, which allows us to define OpenAI functions as pydantic schemas. And the second one is Google Analytics data package. The second package is going to differ based on your own requirements. You can chat with GPT-4 to find out which one you need depending on the API that you're going to use. Now, activate your virtual environment and run pip install-r requirements.txt command. Open the main.py file, uncomment the example function, and rename it into something more descriptive. Since we are developing an internal API, which means it is not intended to be used by anyone outside of your organization, we can use a simple hard-coded token authentication. Creating a public app that uses OAuth and manages refresh and access tokens with custom GPTs involves more complexity. So, if you're interested in learning about how to allow anyone to connect their accounts to your app on GPT Store, let me know in the comments. Nevertheless, I believe that internal applications hold even greater potential compared to those on the GPT Store, and I will explain exactly why at the end of this video. Now, we will add a simple DB token global variable above this function to use for authentication, which you can generate by asking ChatGPT to generate a random token. Make sure not to publicly commit this repo or use an environment variable instead to prevent your token from being exposed. Now, to check authentication, we will simply retrieve the token from the authorization header and then compare it with the database token that we have just defined. If they don't match, we will return a 401 response. To initialize the Google Analytics client, import the Beta Analytics data client and then use the from service account file function. I know that working with Google APIs can be really confusing at first, but luckily the general process is the same for almost all of them. First, you have to go to the Google Cloud console and then select your project. Then you have to find the API that you want to connect, out of hundreds of options by the way. Then you have to enable this API, then click on Manage and get your service account key by clicking on Create Credentials under the Credentials tab. Enter your service account name and then click Done. Click on this service account, go to Keys and click Add Key. Click Create New Key and then choose JSON and click Create. After that, go back to your project folder and drop this key into your functions directory. Again, please make sure not to publicly commit this key on GitHub because I don't want to be implicated if someone hacks your organization on GCP. Then add the path to your service key into the from service account file function. After that, just one more step is required before your service account can access yours or your client's data through the API, which is adding it as a user to the account itself. Since we are using Google Analytics, I'm gonna open analytics.google.com and select the account that I want to analyze. Then I'm gonna click on admin on the bottom left corner and click on account access management. After that, I'm going to click on add user under the plus icon and enter my service account email address from the Google Cloud Console, which typically starts with your service account name and ends with imgserviceaccount.com. This is the tricky part because the queries will be performed by your service account, not yourself, so you have to make sure that it also has the necessary permissions. For our use case, the analyst role should be more than enough. You can also add your service account to as many Google APIs as needed. Next, go back to the admin on Analytics console, copy the property ID from the property details and insert it into our cloud function as a variable. In this example, we will analyze just one property, but you can use multiple properties if needed and allow GPT to decide which one to use. This will allow you to analyze data across multiple websites or streams. The next step is to go ahead and define our OpenAI function schema. Just like in the last tutorial, we'll do this with the instructor library because it is a lot more convenient than JSON. We'll need a few models starting with the main one, GA4 query params model. I will not go too much into the details here because the schema will be different for each application or API endpoint that you create. Instead, I will show you how to add a custom schema for your own purposes at the end of this video. Basically, any doc strings or parameter descriptions will be passed to your custom GPT by using the instructor library, which it will then use to decide how to call your function. Therefore, you should provide clear explanations of each function's purpose in the docstring and the role of each parameter in the field description. Other models in this schema like dimension schema, metric schema, and date range schema define the types for some of the properties in my main schema. For example, date ranges is a list of date range schemas because there can be multiple in this API. Check out the GitHub repo in description for more details. But the most important part in this file is below the if name equals main statement. This piece of code converts our function definitions into the OpenAPI schema that GPT Builder expects. After defining your functions, you can simply run this file to get your OpenAPI schema printed in the terminal. But for now, let's finish the main logic in our main endpoint. You can get your data from the request by using request.getJSON method. We'll then unpack it into our data model and set it as a variable. Another great benefit of using an instructor library is that if the request parameters passed by your GPT do not fit your schema, which often happens, you will receive an error. We can then catch this error with the accept statement and return it back to GPT, allowing it to correct itself on the next request if needed. But if the data is good and it passes validation, we can proceed to constructing a request body. For the Google Analytics Data API, this entails unpacking all the parameters into Google Analytics classes and then calling the run report endpoint itself. The final step is to simply return the data from the report as a string. We are now ready to deploy our function. To do this, simply run Firebase deploy -- only functions command and wait until the deployment is complete. That's it. Your first endpoint is now live and it can scale to virtually millions of users in production. You should also see your endpoint URL at the very bottom. Copy this URL and go back to the schema.py file. Then replace it under service in your schema. Now run the schema file from the terminal again, copy the output, and let's jump into the GPT Builder to test everything out. I'm going to name my GPT GA4 Data Analyst. In instructions, I will tell it to query the provided endpoint and interpret the data for the user. Then I'm gonna hit Add Actions and insert our schema. The last step is to add authentication, which you can do by clicking the Edit button and then selecting the API key type. Paste your DB token into the API key field, select the bearer of type and hit Save. Again, let me know in the comments if you'd like me to explore a more complex OAuth option for public applications. We are now ready to test. The first question I'm going to ask my GPT is how many visitors were on my website this week. As you can see, the model immediately queries the endpoint, and after allowing it to submit the request, it now gets the data and interprets it for us. I had a few active users this week, most likely from YouTube. Hopefully we can increase this number soon. Next, I'm going to ask the primary location of my website visitors for the year 2023. The main location appears to be United States, which I'm not surprised about, but this is already an extremely valuable insight. And finally, I'll ask how much time the users are spending on average on my site. Sometimes the model might not get the first request right, but since we are passing back the error message, it immediately corrects itself and then tells us that the engagement rate is moderate. Honestly, I have no idea where to find this information on Google Analytics myself, so this is already extremely useful. I'm going to save this GPT to use privately in the future. If you want to share this GPT with your own organization or clients, enter a privacy policy URL. It can be any random link, or you can generate it with ChatGPT and host it on a note-taking app like Notion, and then click publish to only people with the link and share it. Now, as I promised before, I'm gonna quickly guide you and show you how to add your own custom logic and create more endpoints for your custom GPT. For example, you can make an action to shorten URLs, you can create a web scraper, or you can connect to any database or a CRM system. The possibilities here are endless. The first step to do so would be to create a new function inside the main.py file and name it accordingly. For example, I am going to do a simple calculator that adds two numbers. Then I'm going to define my schema by copying the schema.py file into the root directory again. I will name my data model add two numbers, and the description for the model would be that this function simply adds two numbers. The parameters would obviously be number 1 and number 2, both required integers without default values. To make one or all of your parameters optional, you can wrap them in an optional type from the type and default Python library and provide default values. Then I'm going to replace the previous model in the name equals main block below. Now I just have to finish the main logic for our endpoint in the main.py file. The process is the same as before. We unpack the request parameters into our model, catch and return errors if there are any, and if not, execute our logic and return the data as a response. Now we can run the deploy command again, copy our new function URL into the schema example file under servers, print our schema and paste it into our new action for our custom GPT. That's it. Now it should be able to add two numbers without printing a block of unnecessary text. In conclusion, custom GPTs is a huge opportunity, but you have to approach it strategically. If you think that you have a unique idea for the GPT store, I can assure you that 1,000 other people have the exact same idea. And if it's really good, OpenAI will most likely release it themselves. On the other hand, if you are developing a custom solution tailored for a specific business, in my opinion, you are much more likely to succeed. OpenAI wrapper startups rarely satisfy all my clients' business needs. Most of them require custom logic or guardrails to ensure that only specific data can be accessed or modified. For example, you can allow the model to store the leads information in a client's CRM while at the same time querying a Salesforce API to calculate the total revenue that this lead can bring in, all in one function without the need to create any user interface any longer. So let me know in the comments what you want to see next. I do read all of them and I try to respond as much as possible. More videos on agent swarms certainly coming soon. So thank you for watching and don't forget to subscribe.